So what we're going to work on in this lesson is finding a way to calculate length so that we'll be able to prove that two segments will be congruent in the future. We know how to find midpoints, we know how to find slope, but it'd be good if we had a way to find the length of a segment, and we actually do. So I'm just going to show you the connection between a formula we already know and this formula that we call the distance formula, but is really just a reworking of something we already know. So I've already done what it asked me to do at the front here. Plot both points, find the midpoint. The point is at 0, -1. Now what I want to do is confirm that the midpoint formula works. And I'm going to do that by calculating this length. And the way that we know how to do that is by using the Pythagorean theorem. We've done that in the past. So go ahead and calculate that distance using the Pythagorean theorem. So I found that this distance is actually 10. And what I'll do next is I'll just check to see if this is the same exact triangle, because if it is, then that distance is 10 as well. And this is a distance of 6, and this is a distance of 8, so that would be the same exact process. So my midpoint formula works. So what I want to do is generalize this idea of using the Pythagorean theorem to find distance, and then we'll use it down here to calculate the distance between these 2 points. Let's say that I didn't know where the coordinates were of the 2 points on the graph, and I just wanted to calculate that distance using general x and y values. Well, this distance here would be the difference between my x values, so that would be x2 minus x1. And this distance here would be the difference between my y values, y2 minus y1. And if I were looking for this distance, I would do the Pythagorean theorem on this triangle. So I'm going to set that over to the side and set it up so you can see what that would look like. So I went ahead and I plugged in my a, which is just this distance here, x2 minus x1, and my b, which is this distance here, y2 minus y1. And then c is just the distance that I'm looking for, the full length there. If this is going to be called the distance formula, d needs to be alone. So the next thing I'm going to do is just solve for d. Now we have the distance formula, which really is just the Pythagorean theorem reworked. But now it allows us to just directly solve for d and not have to do a lot of the subtraction off to the side and then plug it into the Pythagorean theorem. So let's do that for this bottom example here. We'll plug in what we know. Solving for d, x2 is -2, x1 is 0. y2 is 5, y2 is 0. Now let's simplify. And once we're done with that calculation, we get the square root of 29. So we could actually measure the length of a line segment that connects these, which is going to allow us to say, in a proof, that this segment here is congruent to that segment there, because if I've measured their lengths using the distance formula, which is really just the Pythagorean theorem, that's all that it is, then I can use those lengths to support my conclusions in a proof.